Thank you for the warm introduction. First, let me get the obligatory plug for my company out of the way. So I work for a startup based in San Francisco called Levanto Financial. We are everybody's household CFO, and what this means is we help our customers save more money or cut back on spending on things that are sort of wasteful. On average, we end up saving each of our customers about $12,000 a year, which is like half of a one-year-old BMW. It's pretty significant, and there's a lot of real-time stuff associated with the product, and a lot of data-driven, analytics and dashboards. And so what I'm talking about today is very well oriented towards the kind of product that I built, as my day job. So I'm sort of coming here from the USA, but I'm a digital nomad, meaning I travel all over the place and work out of coffee shops. And most recently, I was in Amsterdam and Switzerland for other conferences, and so it's great. It's great to be able to get outside of the Silicon Valley bubble, where everybody thinks that everyone has an iPhone and everybody uses Google Chrome and everyone has a nice MacBook. It's good to get out into the real world and hear different perspectives on how engineering works. So, in addition to working on a product for this startup, I am an avid open source contributor, and in particular, I'm attracted to frameworks that are very opinionated. And this started for me with Ruby on Rails. Has anybody in here used Ruby on Rails before? Awesome. So this was my gateway drug into opinionated frameworks. And then when I took over as the UI architect of Yahoo's ads and data division, we were looking for something that would help us get consistency in our UI projects. We had so much fragmentation. And we ended up picking Ember and building almost 50 products using Ember around this, hundreds of engineers using Ember. And it turned out to work really well. And lately I've been playing with Elixir and Phoenix. This is an unrelated tangent, but you should definitely check it out if you're interested in like concurrency and performance and an ecosystem that is just starting to get started and blossom. So the focus today is going to be on Ember, but I want to take a step back and look at how we got to the current state of JavaScript libraries and tooling. So we have several versions of JavaScript that we've had to work with here. We had something called ES3. ES stands for ECMAScript. It's just the standard to which JavaScript, the language, adheres. So we had ES3 for a long time, and then there was an attempt to create ES4, but there was so much controversy because they tried to add all of these different things like classes, which we recently got, and there was a lot of contention, and so they ended up aborting that attempt to put a new draft forward, and instead we got ES5, which is ES3 with a little improvement. It's tiny. Like we got some array methods, and we got JSON parsing and serialization. It wasn't a big step forward. Lately, thankfully, the committee that decides what JavaScript is has been committing to release a new draft every year. Whatever they've decided on, we get that at the end of the year, and so we don't, for the things that are not controversial, we don't have to wait anymore. Like things like arrow functions and the new string literals, we can use those right away, and the browsers can start implementing those, and we don't have to wait for them to agree on the things like observables that are a little bit more, a little bit harder to find the right spec for. So in addition to this, in addition to JavaScript, we also use tooling on top of it, because essentially we're building for a document viewer. That's what the browser was originally built as. It was built for sites like Wikipedia, right? It wasn't built so that you could extend it to have a rich web application. And if you showed the fundamental things that we have to work with, just JavaScript and the DOM, if you showed that to like an iOS or an Android developer, they would say, I'm missing 90% of what I should have in order to build something rich. So the running theme here, jQuery aside, jQuery has been useful, for years. But we had Dojo, we had EXTJS, we had YUI, and these were sort of big, huge libraries that included everything: your color picker, your calendar. Every single thing was packaged into this. And this has sort of gone out of style, trying to do the UI kit and the framework all together. So after a couple of years later, we started seeing things with data binding come along. And this is Angular 1 from Google, Sprout Core, which originally came from Apple. So it was a framework they built for MobileMe or iCloud.com. These are very rich experiences that make you think, like, this can't be a web browser. You know, a lot of animation and almost no default browser styling. And then Sprout Core eventually became Ember. The first commit of Ember is actually movement of the Sprout Core 2 code base over into another repository. And then we had Backbone and Meteor as well. Both good options, but not talking about those today. And then most recently, we've got this sort of third generation of tools that focus on components and simplicity and alignment with web standards. Started with React, Polymer came along, and until recently was low performance to the point of being basically unusable. And this is like pre 0.8. It was very, very, very slow. Gotten much better recently. And then we've got Ember 2, which was released about 6 months ago, and Angular 2, which should hopefully come out of beta soon. It's still in beta. And we can think of this in terms of aligning with browsers, because we always want to know what do we have to support. And one thing I want you guys to notice is, as we start moving past this line here, past 2012, we really cannot worry about IE8 so much anymore, right? It's like 7 years, 8 years old at this point, and fewer people are using it. And so what that means is these new things that are coming out, they can be much lighter and they can be much more performant, and we can take advantage of things that are just impossible or prohibitively difficult to support in IE8. And now we're working with IE9, and we've got major versions of each browser that most people are on moving forward. So you have all of these options, but then there are also these micro libraries and other less prominent frameworks, and there are tons of different build tools, and like Grunt and Gulp and Webpack, and you can, instead of writing CSS, you can write less, or you can write Sass, and you can even write different things that eventually end up being JavaScript, like TypeScript or ES6. You can use Babel for that. So you have a lot of different choices to make. And what was popular until a couple years ago was to try to pick the best of everything, right? And particularly when I joined Yahoo, every team, every tech lead had their own little grunt file with their own favorite tasks assembled, and only they knew how they worked. And they had grand aspirations, but what they really end up with, more often than not, is something like this. So, and they decided, well, I'm tall, so I need a big cabin here, and I want to put a big engine in there, and so I need a big hood. But this thing never drives properly, and if you take it to a mechanic, they need to study it before they can do anything. So it's not great. It's not great. We're still missing something. Angular 2, which I'm just going to quickly mention again, very, very promising. It is everything you would hope for, given a chance to completely restart fresh with a skilled core team behind it. Definitely worth taking a look at. Still in beta, and still not seeing a lot of adoption yet, because people are starting to, they want to see what ends up being released as the official first version before they start moving forward. So there's also this thing here. And I've deliberately shown just a transmission here, not a car, because it's a great transmission. React is not a framework. It is an awesome library for syncing data with DOM, right? They use a virtual DOM, and they can help us never have to really touch the DOM explicitly. And when people see React and they see performance and they see simplicity, they think, I'm going to build this really fast app. It's going to be amazing. But unfortunately, more often than not, what ends up happening is this. Because the transmission can be fantastic. React is great. But there's huge fragmentation in terms of how are you building your project? What are you using for data? Are you using Alt? Are you using Flux? Are you using Redux? Are you using multiple stores or a single store? There is huge fragmentation. And as a result, if you go on Stack Overflow and start trying to go through React-based questions, the first thing is well, first off, explain the rest of your app. We know you're using React, but how are you syncing, how are you dealing with build, and what are you using as a programming language? So what Ember tries to be is this. It's a car that works, that is not aiming to be the race car, but aiming to work quickly, reliably, all the time, and to get you doing what you need done with as little effort as possible. Now, it's tempting to try to build this. As engineers, we really want to build this. This is awesome. But this takes like years to make, and if you run this car around the track at top speed, the tires will melt off the wheels in like 12 minutes. So it's not really usable, and it's very expensive and difficult to maintain. So just remember, like the goal here, at least for this talk and what we're thinking about today, we want to make sure we're aligned with what our users want to build, which is not always the most amazing, interesting technology that is top on Hacker News, and that's not the objective. That's not what puts money in our pocket. So let's talk about what we mean when we say the Ember ecosystem, because it aims to be very complete. So we've got a couple things here. We have build tools, and that comes by way of something called Ember CLI. If you've ever used Yeoman to create a starter project, this is very similar. You can create a new project, you can set up a new template, a new controller, you can set up tests that are already stubbed out for you. All of that work is taken care of. It's a very fast asset pipeline, which means intermediate build results as you save files. They're under 200 milliseconds. Very, very fast iterative loops as you write code. And then, along with Ember CLI comes a great plugin ecosystem that I will talk about a little bit later. Ember.js is comparable to Meteor or Angular 2 in that it aims to solve the whole UI architecture problem, not just syncing data with DOM, but how do you handle loading the right template? How do you handle routing? Along with this, we have Ember Data, which is a persistence library. It's essentially how you define talking to your API, and then some officially supported libraries for animations and for dealing with virtualized lists, which is like a list of 100,000 items. How can you load all of that so the user feels like they're scrolling through thousands and thousands of items without making the browser get slow? So what makes Ember special is that it's very opinionated, and if you wanted to kind of think about opinionatedness as it applies to some of the choices we have today, React might assume that 50% of all of the apps that we write, 50% of the code is not unique to any of our apps, right? Like, no one needs to be writing an event listener for when this input element changed and I want to update this property in memory in JavaScript. Like that problem can be solved the same way for all of us. Angular might believe that 85% is the same, right? That we don't each need to build our own router. We don't each need to define a component architecture because Angular's got directives, and that's a good way of handling it. And Ember's got components. Ember is taking that even a step farther and saying, look, all of these things are interesting, but we can all share this common code. And so that might be 90 or even 95% of our apps are the same. And what that lets you do is that lets you focus on the remaining 5%, and that's what makes your product unique. That is, how are we handling, like how is the user flowing from screen to screen? You can really operate at more of a product level and not have to deal with nuts and bolts nearly as often. So I'm just going to dive into a couple of the features of Ember and how some of these problems are solved, and then we'll write a little bit of live code and show some demos of things that are new developments in the Ember ecosystem. So for templating, Ember uses handlebars, which is, if you've used Mustache or handlebars, this syntax here will look very familiar to you. It's essentially an extension of HTML. And this is nice because you can actually point a designer or a marketing person to an HBS file that contains handlebars. It looks enough like HTML that they can get in there and change some text and potentially open a pull request just using GitHub's web-based editor. Because it's all declarative and not imperative, meaning we don't have a for loop here. This is all just HTML and extras. It's easy for anyone who already knows how to work with HTML. So they're compiled at build time, and what that means is this text that you see here in the yellow box, as part of the build process, is turned into this, and All you need to worry about here is that it's the imperative instructions for assembling DOM that corresponds to this template that we had here. So if you see hello and strong, here we've got hello and we've got strong, and just take it from me, this is the JavaScript that's required to programmatically build up this DOM fragment and then append it to the appropriate parent element. The magic here, the great thing about this, is that we can swap out the template compiler and the thing that actually goes and retrieves the template and is responsible for putting HTML into the view. We can swap that out with something that's way more performant, way more advanced, and you should not have to change anything about your app, right? That's all inside a black box. HBS files go in, HTML is rendered on the screen, and we've seen, what I'll show you later, it's like 2 orders of magnitude faster than it used to be, but essentially the mechanics of how you consume this as a developer are the same. So in addition to just inserting data into the HTML, we can use what are called helpers, and helpers can have a block form or an inline form, and just think of these as if they're HTML tags. You can have like an input that's only one tag that's sort of self-closed, or you can have like a div which can have an open and a close and a body inside. And these are easy for anyone that has been working with HTML to understand. They're similar in concept. And under the hood, you can just think of these as functions. They're just simple functions that return a string. And so here we've got an implementation of if, and then the block form. You can just think of this block here as a callback, which is then evaluated in the case that the condition holds true. So we have our own way of handling loops in a declarative way, where we can use this each helper, and then you can see there the callback just has this argument item, which is then passed in here, and this is how you would create a list programmatically. And when you do this, all of the bindings, all of the listeners are set up appropriately in an efficient way, and in fact, when you change things, we batch all of that work together so that touching the DOM is something we do infrequently. It's one of the most expensive things about updating the screen in a web app. It's not touching memory, that's fast, it's touching the DOM. And so we try to coalesce all of this work together that happens, within a small period of time. So templates are great, and this is way more flexible than if we were just using HTML. What about transitioning from page to page? So Ember has a router built in, and it's a very similar router to what Angular 2 uses, and almost exactly the same router as what React router is based on. And it essentially models your app as a finite state machine, where you have the URL driving changes in state, and what ends up happening is essentially this. So a URL change tells the router to hook up a controller and a template, which is sort of the JavaScript that handles your behavior, and then the template that renders your data on the screen, and events are attached through the template. It wires all of that up, and then any data that needs to be fetched in the meantime is handled within that transition. And one cool aspect of how this router works has to do with promise awareness. So how do we handle asynchrony? But first I want to go through how one might conceptually think about how a router works. The easiest way for me to think about it is as a tree, where you've got sort of several different levels of your state machine here, and changing URLs just amounts to pivots within this tree. So if we're at the slash route, which is like index.html, we'll see the application route is active and the index route is active, and we can you can relate to this as just index.html. If we then go to the posts page, you can see that we've essentially made a little pivot on the application route here. And so nothing's happening up here. This is staying as is. This guy's unloading, and these two are sort of coming into their active state. And then we can keep pivoting around, and essentially what's happening here is those transitions are happening. If you look at this top right, that's sort of a very basic representation of how your screen might look. You can see that we're dealing with like a nested, a change within a nested view there. So we've got this thing called an outlet, and that's sort of where child views go, and that's sort of a blank to be filled in by new views that we transition into. So I will demonstrate how this works briefly in just a moment. Components are super important for any of these modern frameworks and libraries that we use. And the idea here is to create an encapsulated piece of view and behavior that has a very explicit contract with the outside world. So it's not going to have any funny side effects manipulating global state. We should be able to have a good life cycle around these things and rely on being able to use them just like HTML elements. So who here has used some form of web components for 5 or more years? So who's been writing UI code for more than 5 years? All right, so some of you are lying to me. Who's used this before? An input. All right, so if you turn on some super secret Chrome flags, this is what an input actually looks like. And I'm sorry if it's too small. But the internals of the input have this element called a placeholder, which is a special div. It has some classes added to them for styling. And there are some events hooked up within the input. So we've been working with components this whole time. And the holy grail, like what we're aiming for, what we're trying to align with, is something that looks like this. And this would be like, we would call this a W3C web component. This is sort of something that is part of the HTML standard. Unfortunately, they're not ready. The spec is incomplete, right? And that means that even if we align with it perfectly, there are problems that are not yet solved by the decisions that have been made so far. And this feeds very well into what we heard in the keynote. What we're building, what we're using, no matter what we're using, it's sort of a shim to help us take a document viewer and update it so it's like an application platform. So we have some useful primitives to work with. And this is great. This is a good thing. So the way things worked until recently was the TC39, which is sort of the JavaScript standards body, they all get into a room and decide we're going to add arrow functions, and someone makes a proposal and it gets voted on. So it used to be that they would make decisions, and then they would say, all right, the decisions are final. And then the browsers would go and implement this stuff. And then we would all hope that everything works the way we want it to. Now it's sort of reversed. Now we're using things like with Babel or with TypeScript. We're able to use these things before they're actually part of the draft and give feedback upstream to TC39. And it's good that we're sort of ahead of the draft, because now we know that what gets made official is what actually works, because we're using it in our apps already. So essentially in the Ember world, things look very similar. We don't have angle brackets. We have mustaches, but the components still have a very similar contract with the outside world. They have a very well-orchestrated lifecycle that is equivalent to jQuery on ready, right? This is what you would use to initialize a jQuery plugin. So we've got the ready hook, and then we've got, because we're building a single page app, we have to tear things down appropriately. So this is a great primitive, and you can really isolate these things from the outside world and reuse them extensively. Additionally, we have this thing called Ember data, and just in the interest of time, I'll say it can talk to any API, and the big difference here is you describe how your API works rather than having to deal with the particulars of your API with each request that is sent out. So you essentially create a persistence layer within your app. And the benefit of this is if something changes, it's easy to change in one place, and you don't have to deal with updating a bunch of AJAX calls in 15 different spots in order to make everything resume working again. So we have simple models that are just defined by attributes and relationships. And by default, relationships are asynchronous, meaning, and they're loaded just in time. So you would, in this case, you have a book with chapters. You would access this chapter's property, and you'd get back a promise that would resolve with the array of chapter objects. And there's another layer where you would deal with the particulars of sending that request out. We have a store, which basically is a single atom of state. So under the hood, it works almost identically to the way Redux has evolved. We have one place for each record, and that means that we can bind events to that one copy of the record and rely on the fact that changing it, no matter where we change it, will update anything that has a concern for that stuff. And very easy to deal with retrieving data, right? You see there's no mention of AJAX here, no dealing with promises, and this is just different ways of retrieving data. Using a cache if you want to, so we have a client-side cache to avoid having to refetch things that have a long lifetime. and a couple other objects here that I don't have time to go through. Apologize. So I just want to really quickly show you Ember CLI, this build tool, because it's pretty amazing, and in fact, it is the basis for Angular's new CLI that they're coming out with for Angular 2. They actually bring in Ember CLI as a dependency. All right, so I just want to show you guys some recent developments, and then we'll open up for questions here. And I think I'm just going to pick one to focus on, and it's our new rendering engine. It's called GLIMMER 2, right? And the best way to show you this is to talk a little bit about performance. So in the early days of Ember, we were getting trolled a little bit by the React community because there were certain cases where everything ran, basically horrendously slow. So here's like a whole bunch of components on the screen, hundreds. And this is essentially the Ember re-rendering as fast as it possibly can. It is, for this version of Ember, which was like 1 year ago, this is like the worst case scenario. This is where we perform worst. And I'll show you the React equivalent just so you have a point of comparison. It's pretty embarrassing. All right, big difference, huge difference. So we basically took this weakness and used one of our greatest advantages in order to solve it, and that was the fact that we can swap out that compiled template with something that does completely different things, and we can get a major performance boost without forcing people to rewrite their whole code base. And in addition, we decided to make a new test that more accurately represented what developers have to really deal with. And it has similar constraints. Let me start something up here. And so the idea is we want to have a lot of components on the screen, all updating really quickly. We want them to retain their componentness. And also, we don't want to have to, we don't want to lose state in the DOM. And so if you've done something special to your DOM elements, we don't want, as a result of the re-render, to have everything get completely redone over and over again. All right, so this is our updated test. And this is actually a more recent version of Ember. This is after our first pass of improvements. And the only thing I want you guys to see here is this frame rate is less than 1. This is less than 1 FPS. This is working as fast as it can. And so this is a much harder test to pass than what we were working with before, with the big example with tables. So this is the upcoming rendering engine. And it's named GLIMMER because it's a separate library that you could use with whatever technology you wish. All right, and so this is how fast GLIMMER runs with this much more difficult test. And these are each individual components. And if we actually inspect element here, we can see, like, you can see the animation working here, and I can in fact add a class. And this is proof that we're only changing the attribute on this element. We're not tearing the whole chunk of DOM down and inserting a brand new element. Any changes you make stick. This means we're being very gentle in terms of how we're touching. And even with dev tools here, we're close to 50 FPS. Unfortunately, I don't have the React demo that works with this example here, but it is on the order of like 22 FPS. So now we have basically 300% performance for a case where 1,000 components are on the screen, updating constantly. And we get to, because we're so opinionated and because we have such strong conventions, we can let everybody take advantage of this. So with that, I just also want to say things are constantly evolving, and one of the things that Ember developers notice when they switch to the framework is we release a new version of the framework every 6 weeks. And the idea here is that makes the upgrade process easier because we can deprecate things and start throwing warnings before we rip them out and change them. And so you kind of constantly want to keep up to date. The benefit there is it's as if you have a huge development team working on your project, and you get the benefit of hundreds of people's work without having to wait 6 months and another 6 months and another 6 months. So with that, I just want to invite you guys to show up to my workshop. What we're going to build is a desktop app with Ember.js. We'll use Electron, which is the technology that Slack uses. Slack is an HTML and CSS and JavaScript app. So we'll use that same thing with an Ember app and deal with animations. And I will hopefully be able to live code this thing. It'll be a GitHub pull request viewer with organizations and repos and pull requests and comments and the ability to submit a new comment. We'll be able to do all of that in about 2 hours, which I would challenge anyone to try to do that with a less opinionated technology, because you need to be able to just drop things in really easily and have them automatically work out of the box. So I hope this will highlight some of the great strengths of this option. Thank you, everybody, for your time. And if you have any questions, I think we have a couple minutes. I'm going to leave this on the screen just for fun.
Thank you very much for a great presentation. And just in general, just about testing, how it goes, and are there any specifics in whatever that is?
Yeah. So I've personally put a lot of time in contributing to the framework and the tooling when it comes to testing. And I think we have a great solution for component tests and for acceptance tests. Component tests, you just write a little piece of handlebars to set up your scenario. Like you have your component and maybe another one that is, bound to it in some way, and that is your whole world for doing that little, integration test. For an acceptance test, what I've been working on is bringing async and await, which are upcoming JavaScript language features that let you write asynchronous code as if it's sync code. And this makes it much easier for developers to maintain and read when you can just say, like, visit this URL, and then the next line is click this button. But really, in between those two lines, you've sent an API request out, and you've gotten a response back, and maybe you have an animation that's completed. And so that's another place where the opinionated nature of the framework really shines. We can take care of all of this annoying stuff that if you had a more DIY approach, that's your responsibility to deal with that complexity. And so we try to make it as easy as possible.
Thanks.
One, two, three. Just wanted to ask whether Ember has some already implemented typical stuff like model, date picker, or whatever. So
yes. So there are not officially supported UI kits. In fact, we're a little bit philosophically against the idea of saying here's Ember and then here's Ember UI, and just because those are usually very heavy pieces of JavaScript and they oftentimes need to be customized quite a bit. We do have great wrappers around Bootstrap, around all of the material design frameworks. There are tons. Like if you go to emberaddons.com, we have a website that actually scores all of these different things based on how active the projects are. So here, if we just did Bootstrap, so we've got date time picker, we've got a bunch of buttons, validation frameworks, and part of what's great is all of these are a one-line install. You just do Ember install, Ember Bootstrap validations, and it will actually set itself up and ask you if you want to insert these little pieces of code into your app, almost like using a git diff, saying, here's the proposed change that it wants to make. We're going to add this path to your SaaS environment so we can pull in Bootstrap SaaS. We're going to set up this in your configuration. And it's very easy to make pluggable pieces of functionality here. Like here's one that deploys your app, your minified JavaScript, to Amazon S3. You drop this in and specify your credentials, and it takes care of the uploading and talking to S3 and everything for you. It's very hard to find such a rich ecosystem without everybody being on the same page, structuring their app the same way. So it's another place where it shines. Any other questions? One more.
So Angular uses a kind of same way of templating when you write templates in HTML. but it has a flow when the page is loading. You can still see your ugly templates, which have not been like beautified by Angular. Like that Ember has that flow.
So I'll show you what an Ember template looks like. Let me look at Vine. Anybody use Vine in here? It's like the short little videos. Oh, Vine.co. Inadvertently advertising for some other company here. So if we look at the templates here, and part of what's cool about Ember is because it's so opinionated, I can use my little Chrome plugins and really probe into how their app works. So here we've got, it's basically div soup, right? Lots of divs, and you see here's an Ember ID. What we're working towards and what will be available within, we hope, the next like 3 or 4 months is using W3C web components just as a placeholder so that you could actually go here and you could see, rather than like Ember 467, you could see something like bracket vine-player and have something that is more meaningful to the structure of your layout, right? But in the meantime, this is what we have here. The thing that makes Ember templates and Angular templates a little different is, in my opinion, Angular 1 does too much in the template. You have a lot of behavioral stuff hooked up there, and you're dealing directly with like scope, and it's not. If you think about how long it would take to learn how to do that, starting with HTML, building an Ember template is quite a bit easier because it's sort of it's doing less and it's more declarative and more aligned with web standards. Simply, and this is the advantage of having, being able to learn from the Angular way of doing things. You know, it's not that one is better than the other. One is just newer than the other, and we had a better understanding of where the standards were at when we made those choices.
Thank you.
I can.
Last.
Oh yes, sorry. He's making a very good point. I should show the Ember inspector. So this is a Chrome plugin that is part of the Ember ecosystem. And we can see, like here, I'm looking at Vine, but I can see all of the different routes here. You can see what versions of everything they're using. Looks like they're still using Ember 111. But we can actually get a hold of all of these controllers and see state. Another thing that benefits from a conventional setup. We know exactly where to look for all of these objects and how to tap into the router. And so this is, developers, even the core team, are using this every day. It's like the best way of getting a view into your app's internals and monitoring state. And I think I'm out of time. So thank you very much.